Ni hao. My son is 4 years old, and he's studying a bit of Chinese. It's a third language at school. So when I told him that I was coming to China and I was going to speak in front of a lot of people, he said, "But you don't speak Chinese, they're not going to understand you." And I definitely don't speak Chinese, sorry about that, but I hope you will understand this talk. Please feel free to ask me any questions afterwards if there's anything you want to clarify. So let me start with this a bit spicy title, right? Make Postgres yours again. Isn't it ours? And actually, doesn't this title resemble some kind of theme or series of words a little bit used in politics lately? So let me start with a disclaimer here. This talk is not about politics, okay? I want to make it very clear. This talk is just about Postgres. I don't take any stance politically. Thank you. All right, so let's look at what actually makes Postgres special. Just before that, another small disclaimer and presentation about myself. As already introduced by, I'm the founder of Postgres. The company is on Postgres. And I'm also behind the project called Stackers, which is a fully featured platform for running Postgres on Kubernetes. But this is not a vendor talk. I just want to set a direction. So I'm going to try to detail all the players that are part of this industry. So what makes Postgres special? What makes all of us to be here today and to talk about Postgres? Well, there's plenty of reasons. Most people consider the feature set of Postgres its defining factor. It's so fully featureful. There's so many things I can do with Postgres. There's obviously the extensions that actually enhance the feature set of Postgres and make it even greater. They can take Postgres from adding some functions, some data types, or even completely changing the way Postgres works, or even taking Postgres transforming it into a distributed database. Right? So extensions are also one of the main reasons why people pick Postgres. Or its reliability, the solid story behind Postgres. Never failed to me, never corrupted data. It's always there. Data you put into Postgres, you know it's there. Or the community. Here we are. What an amazing community set of people all around the world that use Postgres. But to me, the real defining factor of why Postgres, why people use Postgres, other than the sum of all these characteristics, is that it's open. Open is a very generic term. It means open source. Definitely Postgres is open source, but it goes beyond this. It's the freedom that I can take it and use it for anything. I don't need to ask anyone for permission. It's not behind a single vendor or company or entity. It's open, right? So this is the defining factor of why Postgres. Now, if we look at today, much of the production Postgres is proprietary. Did we lose something? So we get the engine. Yeah, we have Postgres. We don't get the open part anymore. So what has happened? Let's take a little bit of a step back and go around the story of how we have been deploying Postgres infrastructure and try to understand how we came to this point. Let's start with the self-hosting era. Who hasn't self-hosted Postgres, right? I loved it. I still love it. You took your own Postgres, download source code, compile it, or install from a package. You picked where you run it. Took your own data center. Yeah? You created your own VMs or physical machines at the time, installed the operating system, installed the tooling, then compiled Postgres or installed from packages. You decide exactly every part of it. Which software would run with Postgres? We had all this freedom. It was fun, wasn't it? Definitely enjoyed this. Also suffered it. Let's look at the suffering part. This control came with a tax. It took us a big effort to actually do this. So on one side, yes, it was fun. On another side, it required a lot of expertise. And is everybody required, therefore, to become an expert in Postgres? Yes, to deploy Postgres? Well, definitely we shouldn't aim that way, otherwise we cannot commoditize Postgres. But it's what it does, or it's what it was. It required expertise, it requires a lot of time. Now, certainly with AI we can do better, but still, it requires time and expertise, right? And so, it's not something you can do in a weekend. It's something that requires a lot of effort. Real discipline. And one of the reasons why this is like this is because Postgres, and some people have been mentioning this on the keynote before, it's kind of a kernel. And we typically need a distro. We need a set of components on top of Postgres that actually form a stack of components. Let's look at some examples. If we look at high availability, well, first of all, there's plenty of tools in the space. Right? Some of them are favorite to me, Petroni. Some are not that favorite. But they're separate tools from Postgres. You need to understand how they work, to pick the one that you want, to understand how the config file format works, to deploy it with its own dependencies. In other words, it's a rabbit hole. Then let's look at connection pooling. You probably don't want to run Postgres without connection pooling. And guess what? Same story. How many connection poolers do we have now for Postgres? Like 8, 9, 10? I'm already lost. Which one is the good one, or the good ones? How do you configure them? The config file, again, different config file format, right? With its own set of dependencies, potentially. So again, another rabbit hole. What about backups? I guess you get the point. A rabbit hole. What about monitoring and alerting? Here we've got dozens and dozens of tools. So again, a rabbit hole. Wall archiving, similar to backups, tangled with backups, but still its own rabbit hole, especially if you want to ship these wall files to some potential remote location for advanced durability, something like S3. And then operations, for example, upgrades, another rabbit hole. So self-hosting Postgres is a rabbit hole. I get all the control, but it requires time and expertise. As I say, it's kind of a rabbit hole. Then we've got infrastructure as code, IAC. It definitely helped. With AAC, I can write all my deployment in some Ansible or Chef, Puppet, you name it. This code. Then I run this code is versioned. You can keep it in a Git repository. You can submit a merge request that someone else will review, and then we'll deploy it. So this is great. You can automate everything. But it really didn't save us a steal. Infrastructure as code helps to automate, but still is heavily dependent on the environment where I'm running it. If I take it from one environment to another environment, because environments are different, because the networking is different, because the servers are different, you may need to adapt it, and this is very frequently the case. It promised a world where this was not needed, but the reality showed us that it does. And it's also hard to enforce or warranty reproducibility. That if I run the same script twice, I'll get the same results. Because timing is different, a latest version of a package will be different, and so on. So it's a step forward. Great one. But it still didn't fix the problem, and still requires all the expertise to construct this infrastructure as code. Oh, but then we got database as a service. Finally. It's great. It brought back the joy of being able to use Postgres simply. I can just fire up the Amazon console and click, click, click. No, actually, it's more like click, 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 click. But after that, it's still fine. You get a database. You get a Postgres database up and running, production ready. All the best practices applied there. So this is great. I can mine now my Postgres. It's production quality, it's battle tested, and works great. So I very frequently recommend people to run Postgres as a managed service in a cloud, RDS or others. Now, why this has actually, convinced the market that this is the way to go for those who are willing to go on the cloud? It's just a single word: convenience. We are very deep into technology, and at the end of the day, it's very surprising that people make decisions just by convenience. If I can do this in 30 seconds, I'll take this over this solution. It will take me 3 minutes, even though that could be even better. So they play very, very well. They make it convenient. Right? Now, you don't need a lot of knowledge. Just enough. You can take the defaults and deploy Postgres. You need to be a Postgres expert. You can so-called ship on Monday, right? You can go to the office and get it done. And to work the whole weekend or the whole week or the whole month for this. And the key is that there's now this mindset that the service, the managed service, the cloud manages Postgres for us. Let that sink in for a moment. The cloud manages Postgres for us. So who's the cloud? Is it humans? So when we say that the cloud manages Postgres for us, is that there is a lot of people there, and when you click on the command on the web console, or you type a command in the command line, there's someone really quickly there typing all the commands to deploy your Postgres? I see some nodding here from reputable source that is saying that yes, this is the case. Well, it would be funny, but no, it's not humans, it's just software. So, what drove the market to managed services is convenience, and this convenience is not fast humans typing really fast in a keyboard, it's software. So the mode is software. Software that didn't exist some time ago, but software that exists today. Now, let's pause for a second. There's no free lunch in this world, is there? There's always a caveat. So, what did we trade this convenience for? Let's look at this. Let's compare self-hosted versus managed databases as a service. Right? And there's clear differences. Both with advantages and disadvantages. There's no one better than the other. It's just different trade-offs. And we need to be aware of these trade-offs. With self-hosted, I can get a much cheaper cost from the infrastructure perspective. Then we can factor other costs from a infrastructure perspective. It's much cheaper. I'll show you some numbers later. In terms of where I want my server, if I go on-prem, self-hosted, I can do anywhere I want. Obviously, if I go with a cloud managed service, I need to do whatever clouds are present. Some clouds are very well spread throughout the world. AWS is a great example. Some others, or especially second-tier clouds or clouds that are layered on top of all the clouds, they may be very limited in terms of regions. So sometimes you need to have your database maybe far from everyone else. This may not be ideal. Data sovereignty, it's under your control when you self-managed, but it's under the vendors, the cloud, when they host a solution for you, right? Something I'll also have some words about, wall access or streaming replication access is typically gated on managed services. Similarly with extensions or tools, the self-hosting, I can install anything, any extension or any tool at the operating system level I want to use. I cannot do this with a managed service. And this all leads to lock-in or not lock-in. So there's trade-offs. For this conveniency, for this no expertise required, we have to trade something, and these are the main trade-offs. Let me put some numbers into the cost because it's an interesting debate. So this is an example of an instance from AWS. When you compare the cost for a whole month of using this instance on-demand prices of the bare instance EC2 and the same instance when used as RDS, the managed Postgres database service for Postgres. You can see that it's almost 1 time, so let's say close to double the price. So this is the cost, and actually this is the minimum cost of this management layer. Is it worth? It's not for me to decide. I'm sure the answer is in many cases yes, in many cases no. But it's something that is important to understand. This is the cost of the infrastructure difference for a single instance. Now, we can look at a little bit more, I would call it extreme case, but there's other circumstances where the cost difference may be even larger. If I, for example, consider a 3-node cluster, and with a bit of caveats that I'll explain now, I use some type of storage, I can get to almost close to a 5 times more expensive setup. This particular example can be a bit contrived because I consider the use of local storage on the EC2 instance that is considered ephemeral. It's storage that, if the instance fails, will vanish. But the reality is that these numbers reflect a 3-node cluster. And thanks to Postgres replication, if I self-host, I have always 3 copies of data. If I spread them out across 3 availability zones, and of course take backups, this is a setup that is valid for many, that warranties durability, and I can run Postgres. There's actually now 2 cloud vendors layered on top of pure cloud vendors that are offering Postgres under exactly this setup, PlanScale and ClickHouse. They're doing this exact setup. And notice that actually this number, 4.7 here, can be much smaller or can be much higher because here the driving factor for this cost is actually the storage, network storage. With a warranty of IOPS is really expensive. It's really expensive because you have multiple copies of the data, multiplied by the number of the instances, which may not be needed. And to make things even more different, here on the cluster that is cheaper, I've got almost 8 times the IOPS. So even a much faster and a much lower latency disk. Again, this is our trade-offs. But the key question is, under these trade-offs, can we do something to try to bring these 2 worlds together? And there's the last one that is very important to understand, which is data sovereignty. Of all these trade-offs that I've been mentioning, data sovereignty is the one whose shelf life is expiring fastest. It's becoming more and more important to understand where my data is being hosted, under which jurisdiction, which could be the provider's jurisdiction, not yours, can my data be accessed. So we came up, and I'm proud to present for the first time, what we call the Mesmer Manifesto, my server, my rules. These are 8 principles that we believe any Postgres, whether self-hosted or cloud, should adhere to. They're probably already obvious after all the content I've been sharing today here, access to the source code. I want to know which Postgres I'm running. Actually, I gave a presentation some time ago about, which Postgres you're running. So access to the source code is a precondition. I also want to have OS level access so I can inspect how you troubleshoot without OS level access. It's harder, right? And maybe I want to install some tools there to also help me with my troubleshooting. Maybe I want to install any extension, which is another principle. I want to have unfeathered Postgres super user. And very importantly, I want to access my replication stream. If I access my replication stream, I can get to my real data. If it's gated, well, I really don't have access to my changing. Same with backups. Backups, they're according to the Heisenberg principle, they only exist when I can test them. And in a lot of places I cannot test them. I need to trust the vendor, and they work. So they exist, but I would like to do that to them. And last but not least, I want to have the right to leave. Which in theory it exists. In reality, it is actually quite hard to migrate off of many places. We believe this manifesto should be adhered to every single Postgres service or instance or platform to be provided. Now, given all this, can we bring what clouds brought to the world and made them very successful, this convenience, back to self-hosting? Can we unite both worlds? And for me, the short answer is yes. And it's starting to happen. Open source has caught up. I mentioned before that the node in reality is software. There's no humans managing the databases for us. And if we look at the timeline over the last decade or so, all the software components necessary to achieve this goal have been evolving to a point where they're quite mature. Briefly down this timeline, by 2015 we had the components that actually make the Postgres stack. Connection pooling, high availability, backup tools, they were more or less ready and mature enough to be used. By 2018, we started seeing appearance of the first Kubernetes operators, which actually fulfilled pretty much this vision, with the caveat I'll just mention later. In 2018, 2019, 2020, we started seeing also fully featured packages that were doing Ansible, which helps automate these on-prem or self-hosted environments that I was mentioning before. And by 2021, 2022, we saw the appearance of what seemed to be the most mature, trending, featureful operators now, like Cloud Native VG or Stackers. So we're now in 2026. What's going to happen? One slide more and we will see. But for now, let me make a small brief on Kubernetes. I'm a strong believer of running databases on Kubernetes. I was actually a founding member of a group called DOK, Data on Kubernetes. And again, Kubernetes is essentially just a framework that abstracts away the infrastructure and makes this promise that I can deploy anything anywhere by programming against this Kubernetes API, this guidance, right? So I think could fulfill this vision. But reality is that Kubernetes isn't for everyone. It is perceived as something really complex, and it is. You could actually take a subset of it and make a living out of it. And you can deploy databases without having to know 100% of Kubernetes surface. But still, it is complex, it is big. And what I saw over years is that there's a huge skill gap. Kubernetes experts know nothing about databases. DBAs know nothing about Kubernetes. It looks like they're different worlds. And they are. So for those people who believe in Kubernetes, who want to run database in Kubernetes, there are almost perfect solutions already to do this. But for everyone else, not yet. So today, I would like to mention that there is something upcoming in the next weeks, months. Technology, open source, that will allow you to create your own Postgres cloud. Run Postgres anywhere you want. No dependencies. Take the Linux host and run it. Control from a central place and run under your own terms, fully adhering to the Mesmer manifesto that I mentioned before. Create clusters in seconds. No humans typing behind the scenes, it's just software, and it's open source software. And this allows actually to create the infrastructure that both humans and AI need in this time. If you're more interested, I'll be actually giving a talk about this tomorrow at 10 a.m. Feel free to join me. And in the meantime, thank you very much.